Welcome to the Explainer. Today, we are jumping right into a research paper with a pretty long title, but a really simple, powerful idea. EDALoCo. The goal here is to make blockchain development way easier. And if they've cracked it, this could be the key to unlocking blockchain's potential for, well, everyone.
Right, so who's behind this? This is some fantastic work from researchers at the University of Cadiz and the Western Norway University of Applied Sciences, and it was published in the journal Computer Standards and Interfaces.
All right, here's the plan. We're going to start with the big promise of blockchain, then hit the major hurdle holding it back. After that, we'll look at a really clever low-code solution, see how they put it to the test, and wrap up with why this all really matters. Okay, first things first, let's do a quick refresher on blockchain. Think of it like a shared digital notebook. But here's the magic trick. It's not stored in one place. It's copied across a huge network of computers. And every single entry is sealed with some serious cryptography. What that means is, once something is written down, it's basically set in stone. You can't change it, you can't delete it. It's about as secure and tamper-proof as it gets.
And this is a great way to see how that actually works. So, a transaction happens. Right away, a bunch of computers on the network jump in to verify it. Once they all agree, yep, this is legit, it gets bundled into a block with other recent transactions, and that block gets chained permanently to the one before it. That's where the name blockchain comes from, this unbreakable, ever-growing chain of trust.
Now this is where it gets really interesting. On top of this blockchain foundation, you can build something called smart contracts. And don't let the name fool you. These aren't your typical legal papers. They're actually programs that live on the blockchain and run automatically when certain conditions are met. The classic example, a vending machine. You put in your money, that's the condition, and the machine automatically gives you a soda. No cashier needed. Smart contracts are just like that, but for all sorts of digital agreements.
And this simple idea just explodes with possibilities, right? Imagine an insurance policy that pays out automatically the second a flight is canceled, or a supply chain where payments are released the moment a shipment is confirmed. You can build whole systems where the rules are completely transparent and nobody can cheat because it's all locked in on the blockchain.
So this all sounds pretty revolutionary, doesn't it? Which brings up a really big question. If this tech is so great, why isn't it everywhere? What's the holdup?
Well, the short answer is it's just incredibly difficult to work with. For developers, actually writing the smart contract code is only the first step. After that, you have to compile it, which is its own headache. Then you got to deploy it to the network, figure out how to talk to it securely, and then you have to watch it constantly to make sure it's working. It's this massive, complicated process that's a huge barrier to entry.
And this is where a completely different idea comes into play: low code. The whole philosophy here is to change how we build software. Instead of typing out thousands of lines of cryptic code, what if you could build stuff visually? It's basically like building with digital Legos. You just drag, drop, and connect pre-made blocks to create a fully working application.
And that brings us right back to the paper we're talking about today. The researchers created a solution called EDALoCo, and its whole purpose is to be that bridge, to take the super complex, tangled world of blockchain and connect it with the simple, visual power of low code. So how did they pull this off? Well, they started with a really popular open source tool called Node-RED. You can think of it as a visual workshop. And then they built a brand new set of custom tools, or nodes, specifically for blockchain. So now all those crazy hard steps we talked about before, compiling, deploying, they become just another block you can drag and drop. All that complexity is just hidden away. Okay, but a cool tool is one thing. Does it actually work in the real world? To prove it, the researchers didn't pick some easy test case. They went for something absolutely critical: monitoring the cold chain for COVID-19 vaccines. They used an IoT sensor just like this one, a little wireless device that does one job: constantly measure temperature. And this is so important because those vaccines had to be kept within a very narrow temperature range to stay effective. If it gets too warm, even for a little while, they're useless. So yeah, pretty high stakes. So using their EDALoCo tool, they built the entire monitoring system. And get this, it only took 4 simple visual applications, or flows as they're called. Each one does a specific job. Let's walk through them. First, they needed to compile the smart contract. This is basically the rule book that defines the safe temperature range for the vaccine. Now, normally, this would involve opening up a terminal window and typing a bunch of commands. But with EDALoCo, you just connect 2 boxes. That's it.
Okay, step 2, getting that contract onto the blockchain. Again, another super simple flow. This one takes the compiled contract and pushes it out to the Ethereum network, making it live. One click and it's done.
Third, we have the interaction flow. This one's the real workhorse. All it does is listen for data coming in from that little temperature sensor. As soon as a new reading arrives, it kicks off a process that sends that temperature data straight to the smart contract on the blockchain. And number 4, the monitoring flow. This is how you actually see what's happening. This flow basically subscribes to the smart contract and gives you a live feed of every single transaction, every temperature reading as it gets logged. Total transparency in real time.
So what's the end result of all this? You get a secure, unchangeable, and completely traceable log of the vaccine's temperature from start to finish. Anybody, from the manufacturer to the clinic, can look at this data and know for sure that the vaccine is safe.
And here's the proof. I mean, the results really do speak for themselves. These graphs show the actual temperature data that was logged on the blockchain over a full week for both the Moderna and AstraZeneca vaccines. You can see it worked perfectly, tracking every little dip and rise.
And let's look at the numbers. The system logged hundreds of transactions, which is great, but this is the really cool part. See the detected warnings column? The smart contract automatically caught and flagged the few times the temperature went out of bounds. 3 times for Moderna, once for AstraZeneca. That's the system doing its job perfectly, without any human intervention.
So, let's step back. Why is this such a big deal? Because it basically demolishes the biggest barriers to entry for blockchain. It marries the ironclad security of blockchain with the dead simple approach of low code. You can run this whole thing on a cheap, tiny computer like a Raspberry Pi, and maybe most importantly, it's open source. This isn't some expensive proprietary tool, it's available for anyone to use and build upon.
Which leaves us with a really fascinating question to chew on. Is this it? Is the simplicity of low code the key that will finally unlock the door and let blockchain's massive potential out into the real world for everyone?
And that's our look at the EDALoCo paper. A huge thank you to the authors for their insightful research that could help shape the future of blockchain development. Thanks for watching.